Hey everybody, welcome to chapter 5. Last chapter we talked about measures of central tendency, which basically use one number to summarize the typical score in a set of data or in a distribution. But this week we're going to ask the question, well, how spread out is the data around that measure of central tendency? Because that gives us just sort of a better overall picture of what our data are doing and what our distribution is going to look like. So let's dive in. All right, let's get some review in. What is the only measure of central tendency you can calculate for nominal data? The only thing you can do with nominal data is count it, right? Count the number of people who are Democrats or the number of people who are Republicans or whatever. So the only thing that you can actually look at in terms of central tendency would be the mode. The mode. And here are our learning objectives for this chapter. What can we learn about a distribution from measures of variability? How can the range, interquartile range, and standard deviation be used as measures of variability? How the range and standard deviation compare for different distributions, and why the standard deviation calculation differs for samples versus populations. So first up, what can we learn about a distribution from measures of variability? Well, of course, we need to start with what we mean when we say variability. So variability, also known as spread or dispersion, is a description of how different the scores are from one another in a distribution. In other words, variability indicates how spread out the scores are from each other, as well as from measures of central tendency. So we'll talk about that on the next slide. But basically, when there are a lot of differences between the different scores in a distribution, then there's going to be a lot of variability. And so if we look at this image, we've got kind of three different types of distributions. The topmost distribution has definitely some variability because we've got, some outliers that we can see to the right and outliers maybe to the left. So all of those individual scores, they're not all bunched up together. Whereas this middle distribution, the scores are really tightly packed, which is really nice. That means that's going to have low variability, and that means that they're all tightly wrapped around the measure of central tendency. And then finally, the distribution with the highest variability is going to be that bottom one. So variability refers to how different scores are from each other, and therefore how spread apart they are on a distribution. But also that means that variability refers to how different the scores are from the measure of central tendency, so the mean or the mode or the median, right? Basically, the greater the variability or the greater the spread of scores across a distribution, the less accurate and the less representative of that distribution the measure of central tendency will be. And you'll see what I mean on the next slide. So here we have a histogram or a frequency graph with three different overlapping distributions on them, okay? And the distribution with the highest variability is going to be the one in green, and you can see it's really spread out and it doesn't have as high of a peak in the middle. Now, all three of these distributions actually have the exact same mean, but they're going to have really different amounts of variation or variability. And you can see that the high variability means that those scores, again, are really spread apart, so that bottom distribution in green, versus the low variability distribution in red is really tightly packed. So the scores are really similar to each other, and they cluster around the mean. So that distribution with the lowest variability, where all those scores are tightly packed, the mean is actually really representative of that data because all those scores are pretty close to the mean. Whereas in the highest variability distribution, the green line, the mean is not going to be a super good indication of all of those different scores, right? Which is why when we're describing a distribution of data, whatever, measure you're trying to get, again, it could be IQ, it could be height, it could be GPA, it could be stress levels, it could be anxiety, whatever you're measuring, when you look at a histogram of that variable and how the scores for your sample, for your participants are spread across whatever, measuring scale you're using, you want to be able to describe that distribution in two ways. You want to have both measures of central tendency and measures of variability, because for instance, these two distributions that you're seeing on the screen, they have exactly the same measure of central tendency. They have the same mean, which is a mean of 5. But they have really different variability. They have really different spread of data, even though they have the same measure of central tendency, right? So when we're describing distributions, it's really helpful not only to say, here's a number that represents the typical score, but here's another number that represents how spread apart all the data points are. So let's get an example of variability. Let's say I ask 3 different sections of Psych 2111, on average, how many minutes a day do you use your phone? So let me ask you, on average, how many minutes a day do you think you use your phone? So let's say I gathered data on average phone use in 3 different stats classes. Okay. Now what you're seeing here is that we would get 3 different distributions. Now the thing about this is, in this hypothetical situation, that almost certainly if you collect 3 different samples, the mean is going to be different between those 3. So the average phone use, the mean phone use per day in minutes, would almost certainly be a little different, or maybe even a lot different in those 3 different classes. But for the sake of example and this graphic, all of the means, all the averages of phone use are exactly the same. But you can see that there's a lot of different variability between the 3 classes, right? There's lots of different spread between the classes. And let's say maybe one of the classes is like an honors class or something like that. And it turns out, for whatever reason, I'm just making this up, that honors students tend to use pretty similar amounts of time on their phone. So right around 200 minutes, which would be the average. Well, that might represent something like sample C, the yellow line or yellow distribution, because most of the students are spending about the same amount of time on their phone every day. And then let's say one of the other sections of the class is like an online class. And maybe there's a lot more variability in how often people are using their cell phones per day. And so that could be represented by something like the blue line, sample A, which is really, really spread out. All right, let's move on to learning objective 2, which is how are the range, interquartile range, and standard deviation used as measures of variability? And you'll notice that just like measures of central tendency, there are multiple measures of variability, and the most common ones are range, interquartile range, and standard deviation. And we'll also talk a little bit about a measure called variance, which is directly related to standard deviation at the end of the lecture. We're also going to talk about how the range, interquartile range, and standard deviation compare for different distributions. Let's start with the range and interquartile range, which are a little bit more similar to each other than standard deviation, which I'll leave for the end. So first up is the range, and it's definitely the easiest measure of variability to calculate, and it's the simplest measure of variability. All you do is you take the highest score and you subtract the lowest score from it. And so in this top distribution, the highest score on a scale of 1 to 7 is a 7. And the lowest score is a 1, so you just do 7 minus 1 is going to give you a range of 6. On the bottom distribution, the scores are much more grouped together, and so the highest score was a 6 out of 7, and the lowest score was a 4, so you just take 6 minus 4, and the range is 2. So again, as this is a measure of dispersion or measure of variability, a range of 2 means there's less variability in those scores than a range of 6, and that makes sense because, well, those scores are more bunched up closer to, 4, 5, and 6 on the bottom distribution. The downside of using the range is that it's really affected by extreme scores, meaning outliers on either side of the distribution. And you can imagine if, let's say in this bottom distribution, there was just one score at the rating of 1. Well, that messes the whole range up because then the range is going to be 6 minus 1, which is 5. And it'll give you kind of this idea that there's a huge range and that therefore large variability, when really it's just because there was one outlier. So you wouldn't really know. And that's why range might not be the best indicator of variability. We'll talk about maybe one that's slightly better in a few slides. And incorporating some of those symbols we've been talking about, if you want to calculate the range again, it's just the maximum score, which would be x subscript max, minus x subscript minimum, or min, which would be the lowest score in a distribution. And again, this is not like the lowest score possible on a scale of 1 to 7. It's the lowest score that a participant actually scored. So that might be a 1, or it might be a 4, like we saw in the previous example. Interquartile range is a little bit different, and basically you only use this measure of variability if you're looking at the median. So oftentimes, remember from measures of central tendency, when do we use the median? When we have ordinal data or when our data is highly skewed, the median might be the best. If we think about what the median is, the definition of the median is, well, it's the number where 50% of scores are higher than it and 50% of scores are lower than it. And in this upper image, you can see if you split a distribution into equal quadrants of 25% of scores, then Q2, which is right in the middle of that between the second and third quadrants, that is the median. So Q2 is the median, and basically the interquartile range is the difference between the third quarter, Q3, and the first quarter, Q1, which basically means that the interquartile range is the range of scores in the middle 50% of a distribution. And hopefully it makes a little bit more sense if you look at the bottom image there. You're looking at a box plot, which is going to, the box itself shows you on the left, the Q1 is the 25 percentile, and Q3 is the 75th percentile, and so in between Q3 and Q1 is the middle 50% of the distribution. And then if you look down at the actual curve of the distribution, you can see that 50% of the scores lie in that kind of central bit. And so you would have to figure out, well, what are the two scores associated with Q3 and Q1 such that 25% of the data is above Q3, 25% of the data is below Q1. What are those actual scores? And we have to subtract that. And one of the things you probably already intuited is that because we're only using the middle 50% of the data around the median, this actually cuts out outliers. So interquartile range could be a better measure of dispersion for data that you're interested in using the median as the measure of central tendency, because you're only looking at the middle 50% of the data. So you don't have to worry about individual participant raw scores that are like way to the right or way to the left on the distribution. So again, the interquartile range is the middle 50% of a distribution. And that gives you some sense of at least where are most of the scores, where do they tend to be. And what you would do if you wanted to calculate this is you would have to find x subscript 75%, which means the score at which there are, the 25% of the data is higher than it and 75% of the data or scores are lower than that. And then you subtract from it x subscript 25%, which is just saying the bottom 25% of the score. So that whatever score has 25% of the lowest scores in the distribution below it. And what would that actually look like? If we use this kind of boxy example of a distribution to show that in the middle, the median is 75, and let's say this is, scores on on an exam or something. And so the median score is 75, and what we want to know is what's the interquartile range. Well, we'd have to figure out where are the top 25% of scores and where are the bottom 25% of scores. And it looks like 67.5 is the test score that that 25% of people got lower than, and 82.5 is the test score that 25% of people got higher than that score. And so we can take 82.5, which is essentially Q3, and we subtract from it Q1, which is 67.5, and you get the middle 50% of scores, basically. That's what the interquartile range is. And so 82.5 minus 67.5 is 15 points. And so it's saying that, well, within the middle 50% of possible of scores that people got on this exam, we've got a dispersion of basically 15 points within that middle 50% of scores. Here's a question for you. Why isn't the range a great measure of variability? The short answer is that because if you have outliers in your data, in your distribution, you're going to get a very biased view of variability for your sample. If you look at the minimum score and the maximum score in a distribution, well, those will give you at least an idea of the highest amount of spread. But if one or both of those numbers is an outlier, then it's not going to represent the overall data very well. This is definitely the best meme I found on interquartile range. So hope you enjoy, and I will see you in the next video.